The second speaker for today is Neel Smith. Neel received a PhD in classical archaeology, and he has been a professor of classics ever since in Holy Cross College. So Neel was actually a teaching assistant in Dave's IDS class, the class he talked about yesterday for computer technology for non-engineers, I guess. And he has been essentially doing what's called today digital humanities since the 80s, back when there was no internet, big data was not a word, and most of us didn't have computers. And today he's going to tell us how to write scientific applications to help with humanities.
Greetings, engineers. I come to you in peace. When Dave Patterson recruited me along with a group of other grad students to TA for IDS 110, he reached out to galaxies as remote as the classics department in Dwinelle Hall, where I was a grad student at the time. But I never felt like an alien. And in the next few minutes, I hope to convince you that that's a reasonable position to take, because when we think about organizing and manipulating information, we're actually working on problems that scholars have been thinking about for a couple of thousand years. And if you were worried that I didn't have the word future in my title, let me assure you that what I really want to think about with you this morning is how do we think about the future of the past. But let's start with something familiar and simple. Here's an app. You probably have something like this on your phone or maybe on your laptop. This is a sine function. Even a mathematician would call this a function. You put in a value from a specified domain and it maps it to a value in a given range. I put in 44 degrees and find out that the sine of 44 degrees is a little over 0.69. Now, when I was a high school trigonometry student, I had never seen a calculator, much less a computer. But we worked with sine functions. We did have an app for that. It looked like this. In the back of the textbook, you had tables. And in the leftmost column was the domain. You'd read down until you found your value. Here's 44. And then you read across in the corresponding row to find the range, a little slower than the read process we were just hearing about. But here, we can see a value to 4 digits, 6947, agrees pretty well with what my digital app thinks the sine of 44 is, so that's kind of comforting. 1,000 years ago in Constantinople, the same app looked like this. This is the oldest extant Greek manuscript of Ptolemy's Almagest, and it has precisely this kind of function in half-degree increments. Read from 0 to 22.5 on the left side of the page. You have to go all the way down the bottom column on the right to find 44. And if you read across the row, you'll find in Greek numeric notation a 3-figure value. It's extraordinary to me to realize that my experience in school was closer to this scribe's, for that matter, closer to Claudius Ptolemy in the 2nd century, than anything my children ever experienced in school, college, grad school. But that's the reality. And I think as historians, we haven't fully taken advantage of the perspective that this potentially offers. So, full disclosure, this actually is not a sine table. The only trigonometric function in antiquity is the chord, the straight line distance that an angle subtends. But there's an easy equation. I can usually, with this diagram, even convince my classics colleagues that the chord is just 2 times the sine of half the angle. So if we wanted to ask an obvious question, if we're working with this, an edition of this manuscript in digital form, well, is Ptolemy's data, or at least his data as it appears in this manuscript, any good? We're interested in things like the variety of manuscripts and how the data are transmitted. And so we have to understand his Greek notation. Happily, he gives us angle in degrees. That's not a problem. The unit that he measures length with is not the whole radius, but 60ths of a radius, and the 3 digits are not decimal digits, they're sexagesimal. But we can write a function to do that. And so our mathematical function that I plug into my digital app for sines tells me 2 times the sine of half that is 1 value, and my equation of this notation of Ptolemy's comes out with a corresponding value. Yeah, he's pretty good. Yeah. 6 or 7 zeros. Whoever can count that better can tell me. But that's more precision than we had in that 19th century table that I started with. So what I've been working on recently is rethinking what are tables when we see them in a manuscript. And I want us to be good Greek students, all right? Not the kind who sees the word table in Greek and writes down table. I want to ask, what does it mean? And so one suggestion I'm making today is when you see tables in a scholarly text, think of it as an app. And there are even works even have the word tables in the plural in their title. No text, just tables. So I want to suggest that you think of those as a device, a collection of tables for a particular purpose. Ptolemy is an author of one of those, a work called The Handy Tables, hardly studied by classicists. Classicists don't like texts that don't have lots of narrative prose. So this is a wonderful example that Handy Tables, this is a chronological function that lets you map references to dates to a specific day in what's essentially Ptolemy's equivalent of the way modern astronomers work with a Julian day count. It's handy in a couple of senses. No text to distract you, just the tables, just the functions. You actually need this function in order to do the work in the Almagest, even though it's not in the Almagest. So it's pragmatic, handy in that sense. But it also is remarkably handy in the literal sense. At this period, this is, I think, a 9th century manuscript. Manuscripts are generally very large, sort of folio size. This manuscript has almost identical dimensions to an iPad mini. So the form factor is also literally handy. There are others. This is a chronological table that's a similar conception. One I've been working on a lot lately is a grammatical table. And I just wanted to point out briefly, here you can see, I think, there we go, that in the manuscript, each new entry is very clearly set out with this kind of outline capital letter. This is the input, if you will, and here's the output. And the output is set off in a very different script, sort of capital looking. I put these red dots to help you find it, but there's a white space, different script, and even a kind of color highlighting. So you can really clearly see the table, the functional organization of this. Good luck finding it in the one print edition of this from the 19th century. This is an interesting text to me because this is actually an example of unit testing. Now, these are grammatical examples. A sample word. This is the name of the hero Ajax, and if you follow this as grammatical rule, here's the form of the name Ajax that you would use. But it also stands in, so to speak, for every other noun that follows this pattern. It's just we can't test every noun in Greek, so we unit test on Ajax. So these devices have apps that include functions for cached versions of a mathematical computation, like the chord tables, database lookups, and unit testing specifications. And in general, I'm then arguing that when you see tables in ancient scholarship, think of them as the implementation of interactive functions, but they're implemented using ink on vellum or parchment. So my question now, moving beyond that, is how do we today edit or represent text like that? And in this semester, I'm on sabbatical. I'm in residence at a research institution in Washington, D.C. called the Center for Hellenic Studies. And as part of their June research bulletin, I'll be publishing a virtual computing environment that has digital ways of working with these two texts, Theodosius grammar, and a text of Ptolemy that has very interesting features. Ptolemy's Geography, recent scholars have called it a map-making kit. And I want just briefly to illustrate what I've been doing with Ptolemy for you today. It's the largest data set to come down to us from antiquity, more than 6,000 sites identified with longitude, latitude coordinates, and actually a total of 7 dimensions of data. Ptolemy's explicitly concerned in his sort of introductory theoretical discussion with the organization of the tabular data. He talks about issues that we would translate with terms like referential integrity, efficiency of retrieval, and even normalization of relational structures. But before I look at that, I need you to work with me a little bit. You don't get a free lunch today. Here's how you write numbers in Greek. They use the alphabet sequence. So first 9 digits with a couple of extra characters because they didn't actually have 27 characters. It's a place value system. So the first 9 in the sequence are the ones column. There we go. The second 9 are the tens values. The third 9 are the hundreds values. And you combine them left to right. If alpha is 1, iota is 10, then iota alpha is 11. Rho is 100, rho alpha is 101. No need for a 0. It's given to you in the value of the character. And I won't test you on all 27 values, but I'd ask you to hold on to these two that I've highlighted in green, okay? So here's the one that, it looks kind of like an H. It's the Greek letter eta. Eta equals 8, easy mnemonic. Eta is 8. And hold on to this single stroke, the iota. That's our 10. So one stroke for 110, eta for 8. And with that, we can read Ptolemy's geography. But I'd like to read it not with a web browser, but with Google Earth. Ptolemy's data are in longitude-latitude coordinates, and I'm using a couple of his other properties to distinguish the coastline in blue here from interior points in the dark color. You can see that topologically it's recognizable. You can recognize Italy, the Balkan Peninsula, Sicily, the North African coast, but it spans way too much of the globe. And so problem number one then is, where did Ptolemy's data come from? And we can confidently say, if you have reasonable-looking topology, but it covers too much of the Earth, it's ground data. It's not astronomical observation, no matter what he would wish we could do without astronomical observation. So Ptolemy notoriously uses too low a figure for the size of the Earth. He says it is 180,000 ancient Greek stades. Most other scholars of his period used a figure of 250,000. What if we rescale? Here's Ptolemy's data rescaled, and it looks much closer in size. Of course, it's still a little disorienting because Ptolemy didn't use Greenwich, England as his origin of longitude. Much more sensibly, he puts 0 of longitude out in the Atlantic, so he has no negative values, only positive. And here's what happens if we figure out where he measured latitude grounds from and where his origin of longitude lie. All of a sudden, these 6,000 plus points line up astonishingly well. And in fact, I'll color it now with the provinces and countries' properties. So that'll make it easier to recognize, well, one remarkable thing, the coast of India and Indochina are as good as the familiar North African coast of the Mediterranean, where Ptolemy himself lived and made astronomical observations. That's a completely unexpected result. And I think one point that's the wrong color here. And what's this point from the Indian coastline doing floating out in the middle of the sea? Well, of course, it's linked to another view. This is an alternate view of the same data. This is the familiar textual view. Okay, who remembers? There you go. So here's our latitude value, 18, 18, 18, 18, 18, 18, whoop. One little iota slipped out. It's 8 instead of 18. And if you make that change, guess where it lands? Spot in line with the rest of the coastline. Everything works perfectly. So that's just one small example, but it shows that act of editing is a scholarly research project. It's iterative. You learn new things about your text. That provokes new ideas about how to work with it, analyze it, publish it. That leads to new discoveries. In working with my grammatical text, for example, I discovered as I was trying to work on Greek morphology that every published algorithm for analyzing natural language morphology fails on ancient Greek. Whoops. So we do more familiar kinds of analysis. I'm not going to talk about that today, but I just want to tip my hat in particular to any of you in the room here whose work has contributed to Apache Spark, because I think you've probably saved a couple of my students' summer research projects. Thank you. But I would like to close with one story that's not just about the technology, but perhaps for me the most important aspect of getting to work with Dave Patterson was the new perspective it gave me on what collaborative scholarly research could be like. Some disciplines have claimed the term citizen science, and I'd like to broaden it to refer to citizen scholarship, including humanities work, and tell you just a quick story about the oldest manuscript of the Iliad. It's in Venice, in the Library of St. Mark, and I was part of a team that photographed that manuscript. Sounds nice, but we were not working in the sunlit cafe with the $12 espressos. We were in a repurposed closet, essentially, and it was hot as blazes in there. But with this handmade rig that held the manuscript in place with a light vacuum, untouched by human hands. And the reason we're so interested, here's the opening page of the Iliad. All of those colored blocks are texts that are not the Iliad. They're commentaries, notes, many of them citing scholars from the Library of Alexandria in the 3rd and 2nd century BC, an unprecedented source of information about versions of the Iliad that no longer exist. Rich, just gold for a classicist. This manuscript was first noted in 1788 in a French scholar's publication, and I think it's significant that it made a enormous immediate impact across the world, not just among scholars. One of the people who took notice and was very excited about it was the American ambassador to France, Thomas Jefferson. And so here it's item 36 on page 93 of the handwritten catalog of books he sold to the US to become the core of the Library of Congress, is a copy of that very book. But it's never been completely published. And so part of our goal in taking this photography was to make it accessible. We went to conferences, we published about it, we conducted summer workshops for young grad students, all the kind of conventional forms that we could think of to do what Dave would call a technology transfer. I learned from him how important that is. You don't get to just publish it and say, go find it for yourself. They all failed. What instead we stumbled into was working with undergraduates who don't have to follow any of Dave's rules for how to be a bad grad student or how to be a bad faculty member. And it's probably symptomatic here that the confused-looking member of this intergenerational collaboration is the one at the trackpad, and the one who's pointing authoritatively is the 19-year-old. We have teams working in many different institutions. I visited Leiden in the Netherlands this spring and saw 19 students take over a student lounge. Most of them undergrads, a couple of MA students, and on the far right, the most distinguished Greek scholar in the Netherlands, a member of the Netherlands Royal Academy of Sciences. In the bottom photo, a very sharp-looking crew from Furman University who met with me at a public cafe in downtown Greenville, South Carolina, where they're working as part of this project. And at the College of the Holy Cross, where I teach, an incredibly energetic crew that meets every Friday afternoon when school is in session. I am now known as the last guy to leave campus on the Friday before spring break. These two photos were taken about 30 minutes apart. This is what our research lab looks like at 5:30 on a Friday afternoon. And when you come out for spring break, this is what the Holy Cross parking lot looks like. I don't know if you can see the little dot in the distance. That's my car. So, citizen scholars, but I just want to emphasize that this is not Wikipedia-style crowdsourcing where anybody gets to revert anybody else's work. We use virtual machines, a technology we did not see developing so rapidly, had no idea it would save us the way it has, to create a uniform environment that includes tools for automated validation, and then we use the term verification to refer to human judgment with computer-assisted visualizations. Teams submit pull requests, and these are accepted in the Central Archive if we can replicate the validation and verification. It's a rigorous process, and I'm breaking Dave's 5-year rule. It'll be about 7 years when it looks like for the first time since the 18th century discovery of this manuscript, we'll have a complete edition. We'll have about 150 contributors, and the figure that I'm perhaps proudest of, more than 90% of them will have made their contribution before they had a bachelor's degree. So dare I say, in the 1980s, I worked with Joshua Kosman, now the classical music critic of the San Francisco Chronicle, one of the IDS 110 TAs, to work on trying to parse Greek morphology. This spring, I've been developing a system with the name kanones. It means tables in Greek. It's got some pretty unique features I won't tell you about, but when it's released in June, it will include a dedication, and the dedication is undoubtedly the first time Dave Patterson's name has ever been linked with a project with this small a target audience. But it's what I've got to bring, and so I'm bringing it, and Dave, my hope is that if it ends up changing one life, that'll be enough value to be a worthwhile dedication to you. Thanks very much for everything, and thank all of you for your attention.
This was really fascinating and exceptionally on time. So we do have time for questions.
We do that in the humanities.
And feel free to ask questions in Greek.
Hi, Emre Kocaman from Microsoft Research. I have a question. I love the analogy to apps from tables. What was the equivalent of app stores?
I'm sorry, the equivalent to?
App stores. How are things distributed, checked, reviewed? I don't know.
That was the bottleneck. When you're a good way to think about it is, if you look at the living traditions of hand-copied works, a Torah, for example, might take elaborate production of a Torah might take 1 year, 2 years, up to 3 years. The manuscript that I illustrated of the Iliad is in that level of production. So Ptolemy's Almagest, we have a reasonable number of manuscripts of. Some manuscripts are difficult texts and don't get copied often. It's tedious. One way to think about the expense, this is animal skin. You need a whole flock to slaughter in order to produce this. The manuscript of the Iliad probably cost you 80 sheep or goats. That's expensive before you even get to the labor. So these are these are expensive objects. We need to keep that in mind. This is not a paperback that Amazon will drop on your doorstep. Yeah.
So one thing that inspired me very early in your talk was really that a calculator could be thought of as a way of radically encapsulating a table or a set of tables. And so that got me to thinking about the Antikythera mechanism, which is really, if you like, an ancient method of doing it. So the two questions are, one, or just, I invite you to speculate on this, but one, does the, by looking at what tables were encapsulated in the Antikythera mechanism, could we date it or get better dating or get some feeling of where and how it was produced? And two, given the expense of producing the tables, why weren't there more mechanisms like that?
Good question. I'm not at all confident that the Antikythera mechanism was used. Oh, I'm sorry. Thank you. It's this incredibly cool, it's worth a Google, Antikythera, will find you. It's a bronze device that was pulled out of the ocean about 100 years ago and was covered with crud and accumulation. And it's been cleaned, and there's some really interesting active work going on, doing some kind of scanning approaches to try to read the surface of it more clearly. It's a geared device, and before this, we really didn't realize that they had even technology to work with geared devices in antiquity. And it has tables that, inside a box, you turn a crank and you've got all kinds of astronomical phenomena coordinated. I'm not persuaded necessarily that its application was practical. I think this might have been a showpiece, and that it might have been a kind of, like an orrery, where you can have a model of the planets, and you physically move around, and nobody's using that to calculate anything, right? So I wonder if the Antikythera mechanism falls in that category, and I'm going to leave my interpretation open because we're still just in the last few years getting some really exciting new data from the scanning that's bringing out text inscribed on the bronze that's completely illegible to the naked eye. That was in my wheelhouse.
SD Calais Kairos. You said ask a question in ancient Greek, so that's that's okay. It's all right. It's fine. I just rarely ever get an opportunity to ask a question in ancient Greek, so. I think I might say, is it a beautiful opportunity?
Yeah, Kairos should be masculine. So,
Sorry.
but A for effort. Yeah.
Sorry. No, I meant SD Kalos Kairos. That's what I meant.
Bravo.
So if I can ask a question as well. So what would you tell all the techies here about what kind of tools do you need, basically? So apart from Spark and all the things that you've been using so far, what's the next wave of technology that could really change what you're doing?
Yeah, for us, it's going to be in software. And you are going to outrun our hardware demands easily. And so I really think that a lot of the exciting analytical work is going to be happening with graph manipulation. Very, mathematically well-understood problems. I think I'm going to be attending actually math conference at UCLA at the end of the month, talking about mathematical approaches to text. And if we can get our act together in the humanities field and organize our data right, I think we're going to find that we can do a lot of exciting analysis working with well-understood generic kind of data types, manipulating list sets. But big quantities. And integration with directed graphs is, I think, where a lot of the exciting things are going on in linguistically oriented and humanities projects.
Νίλ, ευχαριστώ πολύ.